Okay, today we're going to learn about the product rule for taking derivatives. So far, you guys only know how to take the derivative when the different terms are being added together. Now we're going to look at situations where you have two different functions that are getting multiplied by each other. So in general, the basic rule is if you had two functions, f and g, if you wanted to take the derivative of that, you would take the derivative of f, multiply it by the original function of g, and then add the original function f times the derivative of g. So make sure you write down the product rule format in your notes. Okay, let's take a look at a couple examples. So first, again, you see this function. There's no plus sign in between. If there was a plus sign, you guys would know how to do that. But right now, we're going to go ahead and use our product rule because it looks a lot like this situation. Our f is x squared plus 3, and our g is x plus 1 to the third. So to take the derivative, we are going to first take the derivative of x squared plus 3. So we get 2x. And then we need to multiply by just the second function. Don't have to do anything to it. Okay, and then we add the first function times the derivative of the second function. So that's 3 times x plus 1 squared. You need to check for the chain rule. Over here, when we were taking the derivative, there were no issues on the 2x, and inside the parentheses, the derivative of x plus 1 is just 1, so that's not going to change your problem at all. So your final answer for this is just 2x times x plus 1 to the third plus, I would distribute the 3 and get 3x, oops, no you can't, sorry, so it's just going to be 3, let's erase that, and just put the coefficient in front, and then x plus 1 squared times x squared plus 3, and that's all you can do. And then there's your derivative. Okay, let's take a look at this one. Your x squared is getting multiplied by the natural log of x, so we have x squared as our first function and natural log of x as our second function. So for our derivative, we're going to first take the derivative of x squared, which is just 2x, and multiply it by the second function ln of x. And then we need to add our original, the first function doesn't change, and then we multiply by the derivative of ln of x, which is 1 over x. And then you just need to simplify. So you get 2x ln of x plus x, and there's your derivative. Okay, taking a look at another example. Now you have 3 products here, but that's okay. You can just think of it as 3x times e to the x. It doesn't change anything. So first, we're going to take the derivative of 3x, and we'll just get 3, and then multiply it by e to the x. And then we don't change the first function, so that just stays as 3x, and the derivative of e to the x is just e to the x. So there's your derivative. Okay, I want you to go ahead and try this function, x to the x squared over 3 times ln of x. Go ahead and see if you get the answer I did. So pause it, solve it, and then we'll get going again. Okay, so in order to do this, you should have taken the derivative of x squared, so your 2 came down to the front, and you got 2x over 3 times the second function of ln of x. And then you're adding, the first function doesn't change, times the derivative of your second function, which is 1 over x. When you simplify everything, the x squared and the x in the second end up just becoming an x in the numerator. So you have 3 across the denominator in both problems, so you can combine everything, and you end up getting this for your answer. Okay, go ahead and pause the video. Try this one. Remember, you're going to, right now it's written as a quotient, so you're going to have to write it as a product before you get started. So it's ln of x squared times x to the negative 1/2. And remember, you're going to have to do some chain rule on this side. Okay, so pause it, give it a try. Okay, so the first thing you needed to do was take the derivative of ln of x squared. So you get 1 over x squared, but then chain rule tells you need to multiply by another 2x, and then our second function stays the same. And then we need to add the first function stays the same, and then you take the derivative of x to the negative 1/2. So your negative 1/2 comes down in front, you subtract 1. Okay, and then we just did some simplifying. So my x and my x squared simplified to just an x in the denominator, and then my x to the negative 1/2 came down to the bottom. In the second function, I had the negative 1/2 get multiplied in the front. My ln of x squared, nothing can happen to that, but x to the negative 3/2 turns into x root x. So as you can tell, your denominator is almost the same. It's just that the first one is missing a 2. So I multiplied this by 2 over 2. So that's why that turned into a 4, so we could get it into one fraction altogether for our answer. Okay, so that's it. We'll do some more practice next class, but please feel free to stop in with any questions.